In this video, I'll be solving this mock or practice exam that I found on crackap.com, and all these multiple choice problems are on polar functions, supposedly. And it's basically on complex numbers, polar form of complex numbers, that type of stuff, in addition to polar curves. Okay, so I pre-solved most of them, but I'm gonna go step by step to explain what I did. Because this might be a new topic for a lot of people, and people get stuck because they're not really good at trig or visualizing things. So I'm going to try my best to explain my thought process through all this. Number one, which of the following choices is equivalent to the complex number this guy? So this is basically asking you to convert from polar form. This is in polar form, in this general type of form. Some complex number z is equal to magnitude of z times cosine of theta plus I sine theta, where theta is the angle between the y and the x component, or is arctangent of y over x. And that's the angle, the polar angle of the complex number. Okay, so this one, we can just multiply through, or distribute this 2 and find the value. So that's what I did. To distribute this 2 to cosine of pi over 3. What is cosine of pi over 3? That is half, plus I times distribute the 2 over, times what is sine of pi over 3? That is root 3 over 2. This 2 times half is just 1. 2 over 2, those would cancel. You're left with root 3 times I. And that's your answer. Okay? This is the complex number. This is a point. This, I don't know what they're trying to do here. They wrote it as one coordinate point, and this, once again, is a point. So this is the only complex number notation. Even we could have just looked from there, and that would have been the right answer. Okay? Which of the following choices represents the complex number k minus ki, where k is less than 0? This is probably key. This is also key in polar form. So our complex number is z equals k minus ki. That's what you tell us. So in polar form, that's this one up here. We need the magnitude and the angle. So magnitude is we take the x component squared plus the y component squared, which is equal to, that's k squared plus another k squared, so 2k squared. So that's square root 2 times square root of k squared. Square root of k squared is plus or minus k. We know k is less than 0, so we choose minus k. Okay? Angle would be arctangent of minus k over k, the y component over the x component, which is, or the imaginary component over the real component. I say y and x, I'm more used to that, saying that. Because when we graph it, the imaginary component is the y, the real component is the x. So this is arctangent of -1. Here we got to be careful because when we find arctangent, it's between negative pi over 2 and pi over 2. That's the domain of this guy. So we would get negative pi over 4, but we're not quite done. Okay, don't just blindly put negative pi over 4. That's not even one of the choices over here. Okay, or negative pi over 4 would be the same thing as 7 pi over 4, but this is not the answer. We got to be careful precisely because I just said the domain of arctan is between negative pi over 2 and pi over 2. Even you calculate, if you put this in, you would get back minus pi over 4. Okay? Here we know which quadrant this complex number is in. K is less than 0. So our x component is negative, because k is less than 0. Our y component is positive, because we have a negative and another negative from here. So it becomes positive. So it's in quadrant 3, actually. Sorry, this is quadrant 2. Counted wrong. This is quadrant here. This is in quadrant 2. So that's why I said over here. Theta is in quadrant 2, so we got to move this angle over here. So we do that by adding pi. So the angle is actually 3 pi over 4. And so our answer is choice B, it looks like. Which of the following choices is an equivalent polar form of this complex number? So once again, we need magnitude and the angle. Okay, so magnitude is x component squared plus y component squared. Once again, it's real component squared plus imaginary component squared. So 2 squared is just 4, minus 2 root 3 squared is just 4 times 3. 12 plus 4 is square root of 16. I'll even write that as an intermediate step, which is equal to 4. So this is the magnitude, which matches all of them, so that doesn't help us eliminate choices. Now the angle. Arctangent of minus 2 root 3 over 2. So arctangent of the imaginary components over the real components. That's over here. So that's arctangent of negative root 3. What is that? Remember the domain of arctan, once again, is between negative pi over 2 and pi over 2. Arctangent spits out something in these two quadrants. So it would spit out pi over 6. Now, what quadrant is our original number in? X is positive, y is negative. The real component is positive, or the x. The imaginary component is negative, or the y component. So it's in quadrant 4. This is also in quadrant 4, so we're okay. We can directly use it. So the answer looks like is C. Write minus 5i in polar form. Okay, so same process. Magnitude, there's only an imaginary component, so it should be 5, but if we go through the motions, real component is 0, so 0 squared plus minus 5 squared, so it'd be square root of 5 squared, which is 5. Theta would be arctangent of minus 5 over 0, because imaginary over real. So it's arctangent of undefined. When is arctangent undefined? That's at negative pi over 2. We could just simply graph this also. Minus 5i would be somewhere here. We can tell the angle is minus pi over 2. And the magnitude, we could just directly take that. It'll be 5, because the distance from the origin is 5. So we could have did it like this also. Or we could have went through the motions of magnitude and angle, calculating them. So the answer is C then. Okay. By the way, you can always double check for these by just multiplying them out, and you should get back minus 5i. Okay, which of the following choices is the equivalent Cartesian form of the polar form, this guy? So this is exactly what we did in number 1. We're going to distribute the magnitude to both terms. So it'll be root 3. What's cosine of 5 pi over 6? That's minus root 3 over 2, plus root 3 times I times sine of 5 pi over 6. What's sine of 5 pi over 6? That's half. So the answer is minus 3 over root 2. Why is that? Well, root 3 times root 3 is 3. Okay? And this is root 3 over 2 times I. So the answer is, looks like it's A, if I picked it correctly. Okay, I don't agree with this question at all. This says, which of the following complex numbers can't be written in polar form? The answer, they say, is B. I don't agree with it, because you can write it as 0 plus 0i. That's totally fine. This is a valid complex number, actually, so I don't quite agree with that, unless I forgot something, unless there's some actual rule where it says that you can't write it like this, which I don't know of, so they say it's B, but I don't agree with this answer, so I would just skip that. This one I also don't like. When they write it like this looks like a point in the xy plane. You don't usually write a point as r comma theta, and they don't even specify that. So I would watch out here. So if you got confused with this question, that's why they assume that this is r comma theta, that you know that this is r comma theta, but I would not assume that at all. Anyway, which of the following choices shows the point of the sky in polar coordinates plotted on the polar coordinate system? So our r is minus 2, supposedly. Our theta is minus 5 pi over 4. Okay, so let's first figure out where is minus 5 pi over 4. So minus 4 pi over 4 would be minus pi, which is over here, and then we go another minus pi over 4. So it'll be somewhere over here. So minus 5 pi over 4 would be somewhere here. Our magnitude is negative 2. So what happens if, first of all, if the magnitude was 2? It'll be somewhere out here, but our magnitude is negative 2, so we just go to the opposite side over here. So it should be some point in quadrant 4. So this is not in quadrant 4. Okay, and the magnitude is 2, but it's not in quadrant 4 because of that double negative. This is for sure not in quadrant 4. This is for sure not in quadrant 4. This one's in quadrant 4. Answer is D. Okay, so I would watch out. I would never write a polar coordinate form in this. I would actually write r is whatever, theta is whatever, or even better yet, write it in like this form. Okay, don't write it like this, in my opinion. Take my recommendation however you like it. I'm a picky grader, so I would not accept that. Okay, this is now on polar graphs. Which of the following depicts the graph of r is 2 plus 2 sine of theta? So these, if you remember like the general shapes of stuff, like which one's a rose, which one's just a circle, which one's a circle that's shifted and all that, that's great. I honestly don't remember most of them. I remember some of them, but I don't remember a lot of them. Like this one is called, this heart shape is a certain form. There's one that like loops in sometimes, and that's a different form. See, I don't remember most of them. I know the possible shapes, but I don't remember the general forms. So when you're in doubt, just plug in some easy values of theta and find your value of r. So when theta is 0, you just plug into here. R would be 2 plus 2 times sine of 0. So it'd be 2 plus 0, which is 2. Pi over 2, this would, sine of pi over 2 is 1, so it'd be 2 plus 2, which is 4. At pi, sine of pi is minus 1. Sorry, sine of pi is 0, so again be 2. Sine of 3 pi over 2 is minus 1, so it'll be 2 minus 2, which is 0. Okay, so let's even look at these first two first, okay? And then I have to flip the page. When theta is 0, so theta is 0 is on the x-axis, is r2? It is. It goes radially outward 2. How about at pi over 2? Is it 4? Pi over 2 is here. It should be magnitude of 4. It's not. Eliminate this one. This one looks like it. Magnitude 2 at theta is 0. Magnitude of 4 at theta is pi over 2. What about pi? The magnitude should be 2. It is. The magnitude is 2 from the origin. Okay? Don't be confused by this minus 2 because we are in the pi direction. So the pi direction is here. And the magnitude going outward in the pi direction is 2. So that's why it lands on the x-axis minus 2. 3 pi over 2, that's down here. Magnitude should be 0. So it looks like B is the right answer, but let's check some more. When theta is 0, r should be 2. When theta is 0, there's two possible choices. It's 0 or 4. We don't have a 4 anywhere when theta is 0 or pi. When it's pi over 2, it's 4, but pi over 2 is up here, so not C. And then similarly, when theta is 0, r should be 2. It should be over here, but there's nothing there clearly, so eliminate that. Answer is B. So when you're in doubt, just plug in points for theta. Some easy points. Don't plug in difficult points. Which of the following polar equations represents the graph below? So that's on the next page. And similarly, I did the same thing. We have 4 possibilities, so I just plugged in theta is 0 first to check which ones I can eliminate. When theta is 0, r would be 3 in this case, r would be 6 in this case, r would be sine of 0, 0, so 0 in this case, and then here it would be 4. Okay, so when theta is 0, what's the magnitude here? 4. That only matches D. As simple as that. We don't even need to do anything else. Okay, average rate of change of the polar curve. Average rate of change is always like this. The function at the end point, the second end point, at the ending point, there we go, minus the function at the starting point, so r of pi over 2 minus r of 0 over the distance between the end point and the start point, so pi over 2 minus 0. You always go like this for average rate of change. So we go through the motions of plugging in. You should get 2 minus 6 over pi over 2, which is equal to minus 4 over pi over 2. So flip this over. It'll be minus 4 times 2, which is minus 8 over pi. Okay? And that's it. See, these polar graph stuff is not that hard, honestly. You just, of course, need to get good practice on it first. But otherwise, you can always fall back to just plugging in values of theta and seeing which ones you can eliminate and all that. Okay. And that's it for this one. This practice test was not too bad, hopefully. And hopefully my explanations were helpful. I don't know what the explanations on the website are. They do provide an explanation and of why the answer they got is, or how they get to their answer. So I didn't look at how they did it, but if it didn't make sense there, hopefully my explanation helps. Or if mine didn't make sense, go look at the website. Maybe that will help you out, okay? Please like and subscribe, as always, if I have helped you in any way in this video.